Last but not least, we're going to be computing the minimal sample size for estimating our proportion P, and this will conclude section 7.3 after this part. So a lot shorter than 7.1, but here we see a lot of the same things that we learned in 7.1 being reapplied in the realm of proportions. So not too much for us to be worried about here, okay? So here we're going to be using our preliminary estimates for P, okay? So that's slightly different than what we've been working with before with this idea of a sample proportion. And those preliminary estimates are going to be given to us in our questions, okay? So here we see that we're dealing with a complement for the preliminary estimate. So here we know that typically when we're talking about a complement for a proportion, we're going to be using Q. Okay. And now we can see the translation into the equation that we see in our formula book here. So when we're trying to find the minimum sample size, we're going to be taking the critical value, squaring it, and then multiplying it by the product of the preliminary estimate and its complement all over the squared value of the maximal marginal error. So now let's take this equation and do an example with it. So here we're going to find the minimum sample size for a study with a preliminary estimate of 0.25 at a confidence level of 95% and a maximal margin error to be 0.2. Okay, so here I changed the number from 2 to 0.2. So my apologies for that. That's what the scribbled out part is here. So we're going to work with 0.2 for the margin of error. Okay. The first step that we're going to do is write out the equation so that we can gather our bearings and write out all of our variables. Okay. So here, our critical value is going to be based off of a confidence level of 0.95, which, as we've seen from our previous examples, is 1.96. Please make sure that you know how to calculate this value during your exams. Here we have a preliminary estimate of 1/4 or 0.25, and its complement is naturally going to be 1 minus that value, which is going to be 0.75, or also known as 3/4. And here the maximal margin error is given to us as 0.2. So that's going to be our last value that we have. Perfect, we have all of our values for the fraction on the right hand side of the equation. So now we can find our sample size. So plugging in all of our values, our critical value is 1.96, and we're going to square that. Now that number is going to be multiplied by our p-value, which is 0.25, or our preliminary estimate, and the complement of the preliminary estimate, which is 0.75. That's all located in our numerator, and our denominator is going to have the margin of error squared. Okay. Plugging in the value of our numerator, the values in our numerator on the top, we have 1.96 squared multiplied by 1/4 multiplied by 3/4, and we get 0.7203 in our numerator, and our denominator is going to be 0.04 or 400ths. Dividing the numerator by the denominator, we get an n value of 18.0075. Recall that whenever we're looking for the maximal sample size, we're always going to round up, even if our tenths place is telling us to round down, because we're going to be trying to get a better margin of error. We're basically working for a better estimate, basically. So here, our final answer is actually going to be 19. Okay, and that concludes our computation for the minimal sample size given an estimate.